If we cede that to them, that will not be very good in the national security interests of the country. If the United States does not invest in these so-called mature technologies, we are going to have a huge disadvantage. These power chips are the ones that are going to drive energy efficiency. Our chips help with that. They drive the fans that do the cooling. They want to dominate the power semiconductor space in silicon carbide. And soon, they want to dominate also gallium nitride.
It's important that we don't repeat that same mistake as the United States, which is why. Hey, thank you for joining us here on the Microjourneys podcast. Exciting to be here at Polar Semiconductor. It's a beautiful campus and one that's been in the positive light of the news for I'd say almost about a year now, especially with a lot of the investments happening here in the United States. But why don't you tell the audience a little bit about yourself?
Well, Daniel, welcome to Minnesota. My name is Surya. I'm the president and COO of Polar, and I have been in the semiconductor industry for about a little over 25 years in the semiconductor equipment industry, the chip manufacturing, and now I am leading the foundry here at Polar.
Yeah, the site here is quite interesting because it is undergoing a pretty massive expansion. But before we get to that, why don't you give a little background on what Polar is and kind of the evolution that's recently happened within the company?
Yeah, it's a fascinating story, actually. Polar in this building has existed as a manufacturing facility of microelectronics since the 1960s. So this building used to be Control Data Corporation. That evolved over many different names, and now in 2005 it became Polar Semiconductor, and 2024, just last September, we became a independent company, private equity owned company, US owned company, and this is our latest version of this facility.
Yeah, the US portion of this is quite interesting and exciting because it tracks a lot of the narrative that has been coming from the White House, from people in Congress and the such, that we need to create a US manufacturing ecosystem. And that is a humongous pivot. Many of the companies that kind of got first in line or tried to be first in line were already US based. So how was that transition from being non-US owned to US owned? I mean, was it a pretty seamless transition, or why don't you describe that a little bit?
Oh, that's a good question. Actually, I think I'm not 100% sure, but we were kind of a unique company that not only is part of this major expansion of semiconductors in the United States, but also an example of a foreign-owned company becoming a U.S.-owned company. I have to say our previous owners were very supportive of the transition. The new owners were obviously very excited about the transition, but these things do take time and they're complicated. There's a lot of different entities involved. And at the same time, we were also applying for the CHIPS and Science Act funding. So this was all of these things coming together was a little bit of a miracle in a sense that all of this had to fall into place correctly. And it did happen. And we're excited about the future.
So when people think of electronics, right, they hear a lot about Moore's law and they automatically think about, node shrinking and things like 2 nanometers and the such. Polar has a very different set of manufacturing capabilities. However, that different set of manufacturing capabilities is a core capability to what makes the world operate and run. So can you describe a little bit about what you guys manufacture here?
No, I'm glad you asked that question. This is the kind of semiconductors that Polar makes. We call them power semiconductors and also sensors, high voltage power semiconductors and sensors. That's Polar's specialty. These are generally manufactured at so-called mature nodes. That's 28 nanometers and above. And we manufacture them. We have been a automotive certified company for a long time. So we manufacture these power semiconductors that go into automobiles, cars, and other transportation equipment. And the key requirement for that is that it has to be reliable. It has to last the life of the car. And you cannot be stranded on 494 in the middle of the freeway because your chip failed. And so quality and reliability is what drives the kind of semiconductors that we make. And that is not just automotive, it is just expansive in applications. There's applications in aerospace and defense, there's applications in industrial settings, commercial settings, medical settings as well. So medical devices also use power semiconductors. Power semiconductors, you can almost think of anything that has to deal with higher voltages and higher power. Anything that turns a motor or has to deal with higher voltage settings needs a power semiconductor. We make power semiconductors at Polar that are power management type of power semiconductors, motor controller type of power semiconductors, and so on. So this is a specialty type of semiconductor that is absolutely essential for any kind of semiconductor ecosystem. And we have had a shortage of companies that can deliver these type of semiconductors or manufacture these semiconductors in the United States. For example, many of the semiconductor devices that are needed for defense applications are actually manufactured outside of the United States today. Now, Polar is an option for making these at home.
Yeah, that creates quite a risk for, I mean, you start thinking about it, you use the example of automotive, right? Having, electronics that are not, just a commercial standard. They have to be, able to function for the, 100,000 miles that your car is expected to run, in extreme temperatures. We're here in Minnesota, it gets cold. I live in Sacramento, it gets hot. So they have this fluctuation of temperature. So now you have lifetime, you have temperatures. It's a very rigorous process to ensure that they're qualified for those types of things. And it's not same application, same type of qualification for all industries. And then you amplify that with aerospace and defense, right? You have everything from radiation effects that impact
Mhm.
your electronic components to, you know, the supply chain associated with this, which you what you just touched on here.
Yeah.
It's a huge benefit,
Yeah.
to that market segment being able to have that. So how, within Polar, how are you guys structured? Because there's a lot of different, companies, in the semiconductor space that are vertically integrated in the such. Some don't take in customer requests. How are you guys structured in fulfilling that, set of domestic needs?
Yeah, that's a good question too. Polar, um, part of this whole transaction where we became a US company, US owned company, was also a transformation in our business model. We were an internal manufacturing facility for our owner customers. Now we have become a merchant foundry. Merchant foundry means that we're contract manufacturers. So there's designers who will design a chip for whatever application that they want to design it for. They will send that design to us and we'll manufacture that chip for them. Side note, a little bit of statistics. The United States foundry capability till like 2023, 2024 was only about 7% of worldwide foundry capacity.
Wow.
The it is even worse in technologies like what we do here at Polar, the power semiconductors and sensors. That capability is even less. And the capability on the other end of the spectrum, the top, the most advanced node technology, is almost non existent. You have heard many, many times, I'm sure, in the news that most of the advanced semiconductors are manufactured outside of this country. So there's a major shortage in foundry capacity. And foundries is what customers in the aerospace and defense industry and other industries are looking for. Because if you are vertically integrated, then you're just making the products that you are going to design yourself, you're going to manufacture them, and then you're going to sell to the end market. But if there's somebody who is a fabless company, a fab is the semiconductor factory that we manufacture these devices in. If you're fabless or fab light, where you want to have the flexibility of doing some manufacturing internally and some manufacturing outsourced, companies like Polar become very, very important. And a very important part of that semiconductor ecosystem, as well as that supply chain resilience. If you can design and send that design to us, we can manufacture it for you. You don't have to manufacture it in Taiwan or China or any other place outside of the United States.
So if I have a terminal, I have a ability to, create a design in power electronics.
Mhm.
What I'm understanding here is that I can take that design and work directly with you guys, and you guys will make me the physical chip, correct?
Exactly.
Okay.
And so our model is even more, kind of a partnership type of model. So if we have customers, we will work with customers. We generally want to work with customers who are partners, and we also want to help them get to the next level. So you want to get from whatever your design is today to the next generation, to the more advanced type of device or product that you want to make. We want to work with you to get you there. So we also have a very strong technology development group, does things like design enablement, transfer of technologies. We also are, do licensing of technologies. We can also transfer technologies that our customers have somewhere else back here. So we can do the onshoring of technologies that are currently being run somewhere outside of the country. So all of these options are enabled by a company like Polar.
So it seems like there's a suite of, solutions that help me in this fictitious example as the designer
Mhm.
to ensure that my product is able to actually be not only manufactured, but have a quality end on the backside. Is that pretty true?
And the quality word is so important. I mean, we as an automotive manufacturer, our culture is a culture of quality. Everything is quality and the reputation that you gain over decades based on the quality of products that you have shipped. So a company like Polar, you're coming and making product that may not necessarily go into an automotive or aerospace or defense type of application where that quality is super important. It may go into a commercial application, but you still get the same quality because it's manufactured in the fab that is certified for automotive and, just exceeding the normal requirements that a typical foundry out there will have.
So when taking a step back to the power aspect, right?
Mhm.
I mean, there's a wide range of microelectronics in general, right? You
Mhm.
have your logic devices. We were talking about power here, but then you take it a layer below. There are a spectrum of different types of power materials that are used. What do you guys manufacture here from a power perspective?
Yeah, so I mean, I love to talk about this stuff because it's really kind of exciting. It's the foundation of most of the electronics that you see out there in the world is power electronics. And power electronics mostly has been based on silicon. Silicon is the foundation of most semiconductors in the world that are made today. But the next generation of power semiconductors is going towards something called compound semiconductors. And so there's a lot of companies that are investing in technologies and manufacturing of non-silicon based power semiconductors. You can get to much higher voltages and frequencies if you go to materials that are beyond silicon. For example, you may have heard about a lot of companies investing in silicon carbide. Silicon carbide is a material that is being driven by the EV automotive space,
EV electric vehicles.
electric vehicles. So there's a lot of silicon carbide content in these electric vehicles that improves their charging and charge retention, things of that nature. Also enables higher temperature performance. Polar has just recently made a investment in a gallium nitride technology. Now, gallium nitride technology is something that we wanted to go with because it is manufactured on a silicon base. And so you're slapping the gallium nitride on top of silicon, which we know how to deal with, but you get the advantage of these compound semiconductors. You can go high voltage, high power. And now we're looking at, gallium nitride being a replacement for a lot of silicon applications in the high voltage, high power space. So we're gearing ourselves as a major provider of gallium nitride silicon wafers and silicon devices in the United States. I think we're the only foundry in the United States that provides a gallium nitride that is production ready and ready to go.
Well, and pure play, which
Eh,
is
yeah,
exciting.
exactly.
Within that, there was a number of different evaluations that Department of Commerce has done, where they've looked at the domestic ecosystem and asked many people in our industry, what is the biggest risk right now? What is the biggest risk associated with domestic manufacturing? And what ultimately came back is, though state of the art is a very sexy thing from a logic perspective and
Mhm.
the such, that really has a niche focus, data centers and things of that nature, maybe some of the gaming infrastructure and the such. But what keeps the world running and the United States running
Mhm.
is, like you said, the state of the practice, some of the legacy related technologies, and that is a major shortage. So being the gallium nitride and power electronic and sensor solution puts the United States in a position to not be reliant on many of these overseas manufacturing. Do I have the story right
You
here?
you have it absolutely 100% right, and that is it is a strategic imperative for the United States to invest in mature technologies of the types that Polar makes. Right? I talked about gallium nitride, silicon carbide. We're also pushing the frontier of silicon. We're pushing silicon performance to high voltages. We're pushing silicon performance to high power. So it's not just the new materials, but also driving the innovation in silicon in the United States. And by the way, the other thing I wanted to mention, you mentioned data centers. Power semiconductors are a very critical component of data centers that drive the future of AI. Because
Which is, I mean, right now got a tailwind that is just accelerating that industry quite a bit, right?
yeah, absolutely.
So having that the integration into that as
Mhm.
well is yet another pillar that not only benefits Polar, but it benefits the investments that are being made into Polar. So that way, it's not something that the question arises of, is there enough stability at the location for people to design into? That stability is coming in from a variety of different places, correct?
Yeah, yeah. I mean, continuing with the the need for these kind of devices and the expertise to be developed in the United States and maintained and grown in the United States is that uh, these power chips are the ones that are going to drive energy efficiency. The AI data centers are going to consume uh, huge amounts of electric power, but power management chips that we make at Polar will reduce the amount of power that's needed. And so we make those AI data centers more efficient.
Interesting.
There's cooling that needs to be done in these data centers. Our chips help with that. They drive the fans that do the cooling. So there's a lot of, as you said, everybody talks about this sexy advanced 2 nanometer chip, but there's a whole bunch of infrastructure, semiconductor infrastructure that has to also be operating at the cutting edge to make some of these things go and make some of these things go into the future. And if the United States does not invest in these so-called, mature technologies, we are going to have a huge disadvantage because the strategy of our adversary, right, for example, China, is that they want to capture all of this mature semiconductor market. They want to dominate the power semiconductor space in silicon. They want to dominate the power semiconductor space in silicon carbide. And soon they want to dominate also gallium nitride. If we cede that to them, that will not be very good in the national security interests of the country.
Absolutely
Yeah.
not. I mean, it creates a dependence for a lot of the stuff that we design here in the United States. I mean, there's core examples of this, right? Look at the dependency that Apple has on China, right? They have invested so much for them to be able to manufacture and qualify a lot of their components that they can't break away from the Chinese relationship, or if they do, it's going to be a major challenge.
Mhm.
So, though that specific industry seems to have that, kind of connection, it's important that we don't repeat that same mistake as the United States, which is why Polar is so interesting. With that being said, and kind of the foundation here, your power electronics, I think that there's been quite a bit of a recognition that people within the government have seen within this. That spurred, your guys's ability to, be one of the first to be awarded with the CHIPS initiative. So why don't you describe a little bit about how that process happened and what that investment is doing here at Polar?
I think it is very important to recognize that a bipartisan group of leadership in the Senate and the House recognized that we have to maintain our leadership in the semiconductor space. And they came up with the Chips and Science Act, was signed into law, and now uh, probably I'm probably not updated on the number, but there's probably over 500 billion type of investments that have been announced. That is a huge amount of investment that has been announced in uh, manufacturing and technology of semiconductors in the United States. The journey for Polar, of course, was very near and dear to me because I thought of it as a huge opportunity, not just me, but the management that we had at our owner customers, as well as the investors who are looking to invest in us. They all saw that this was a huge opportunity to kind of take advantage of this law to supersize what they were already planning on doing. So there was an investment that was already planned to happen at Polar, but it got supersized because
Oh,
of
so
the
this is a natural overlap from a
it was it
timeline.
was a,
Yeah.
it was a great it was a it was a fortuitous coincidence. I have to say that it came in pretty much at the right time. We're going to make an investment. The investors who have invested in us were going to make a big investment anyway, and now it got supersized. Now size matters in the semiconductor industry because it is all about scale that drives cost efficiency. And to in order to compete with similar foundries in China, Taiwan, Korea, Europe, and other places, you have to have the right scale. So, one of the key goals of our expansion, our investment, $525 million total investment that we're doing, is to expand the scale of the factory. We are almost going to double the size of the factory to about 40,000 wafer starts per month, which puts us in a competitive scale to similar companies out there in the world. So that's one component of it. The second,
What are you guys at right now as it relates
we're
to?
about 20,000.
Okay, so
Yeah,
it is a double
yeah,
of
it's
capacity.
exactly. So it's a doubling of capacity. So that gives us scale, that gives us cost efficiency, cost competitiveness. Then it is, ticket for success in the semiconductor industries that you have to be at the cutting edge of technology. Technology drives this industry. And the other piece of that investment is to invest in new technologies. For example, the one that I talked about is the gallium nitride technology that we're working with with our partner in Japan, Renesas. And we've also signed an agreement with Tower Semiconductor of Israel to develop an advanced power management chip technology here at Polar, which will be directly uh, implemented for serving our future defense customers. So we're bringing new technology, advanced technologies that will put us at the cutting edge of serving customers in aerospace, defense, medical, commercial, industrial, and grow our expertise in automotive.
And now with this expansion, I mean, you can take larger volume orders associated with it, which is, kind of a limiting factor when you're at the 20,000 wafer, but 40,000 wafers now, I mean, you can have pretty big ticket, customers coming in that know that this is a reliable, resource that they can continue to monthly purchase, components from. That's it.
Yeah, I mean that's absolutely right. I mean this opens us up for lot of growth, a lot of new customers, big, medium, and small, and we are seeing a lot of interest from customers. And if you come back in a year or 2 years, I'm sure you'll see that Our expansion is completely finished, and we have a whole bunch of customers' wafers running here.
So
By
is
the
that
way,
targeting a calendar year 26, 27?
26, 27. So this was one of the other big pieces of our strategy, was that we were not really going to take that investment and grow the skin of the building. We're going to stay within the skin of the building that we already had, but increase the clean room capacity. So the building now has a lot more clean room than it used to have. Clean room is the space where all these semiconductor equipment is set up, and all our operators and engineers and technicians work in their bunny suits. So there's and so the clean room has been expanded. A lot of clean room has been built. We're very happy with our partnership with companies like Mortenson and others who are the construction partners, and we've really, you know, been able to do this very quickly. Um, the point I was going to make earlier is that our thesis was to not make it a 5-year, 4-year, 5-year project. This was going to be a 2-year project.
And
So
that's smart because you start losing sub vendors that are going to, help out with some of this growth. There's a lot of, political changes. So some of the people that are supporting you today, there may be transitions at all levels, right? I'm not, identifying just people from the Hill or from the White House. I mean, at all levels. You have workforce that has to stick around, which I'll circle back to because workforce is an interesting one.
Mhm.
So all of these aspects, tightening that timeline ensures that there's a higher probability of success with the expansion and not just something like, yeah, like you see those Olympic stadiums that they get built and never used right after the Olympics are done. So
no, I think that's important. The timeline is super critical because part of the motivation for this American investment in the semiconductor industry was born out of the supply chain issues during COVID. And during COVID, um, we were part of the solution. We were building chips that go into life-saving technologies. We were making chips that go into respirators, right? So we retooled very quickly to be able to make chips for respirators. So that that's kind of our thesis, is that we wanted to be at the forefront um, of that issue with supply chains. The supply chain resilience is that we wanted to get in front of that supply chain resilience problem, and the timeline was based on that. So we wanted to get to a place where we could be a supplier of advanced semiconductors needed for a variety of applications in the United States and solve that supply chain resilience problem.
Another interesting thing that I've, been able to see firsthand, I've been fortunate, is you guys have streamlined a lot of the operations internal to the fab. So when I was walking around and I got my tour, I almost get bumped into, of course I don't, by this little robot that seems to be buzzing around your guys' fab. So it seems like not only are you guys pushing the technology advancements, but
Mhm.
also the operational advancements to ensure that there is a streamlined approach on how you guys are manufacturing to ensure that that expansion, is not impacted by, whether it be workforce or whether it be, just mishandling of items in there. Your those investments seem to be interesting. So, what else would you like to talk about as it relates to kind of streamlining the processes?
No, the other piece of semiconductor world in the semiconductor industry is that cycle time matters. Everything has to be done quickly. Our customers are interested in quick turnaround of new technology, quick turnaround of new products. There's products coming up and online all the time. And so we knew that to be able to compete and be a top class provider of foundry services, we needed to make sure that we are at the best in class in cycle time, delivery, on time delivery, and cycle time. And to make that possible, we needed to automate the factory as much as we could. So we came up with a plan that was a balance of automation and human, our operators and technicians. So it was not a complete elimination of people who are working in the factory, but in a way, making those operators and technicians more efficient through the automation that we were going to add. And that's what we did. So we've added robotics, autonomous robots that you bumped into. They probably excused themselves as they walked in front of you. But
They were
anyways,
very polite.
and also we're embarking on a major automation project, overhead transport. So the materials, the boxes that contain these wafers, that contain the devices, are transported up on the top, on the roof, or near the roof, just underneath the roof. That system is being put together.
Oh, that's
And so
awesome.
that is all of these things are going to make Polar a very efficient foundry. And efficiency is critical to competitiveness. At the end of the day, if I have to rank things, technology is number one. If you don't have the technology, then your customer's not interested. Then you have to be cost competitive, and you have to be, in order to be cost competitive, you need to be efficient, and you need to have the smartest, most skilled and hardworking people. And I know you want to get to the workforce development. I'm kind of getting to there right now. It's the people who actually, at the end of the day, make the company successful. And what we have done in this transformation of being an internal factory to a foundry is that we have really made a huge investment in our people.
Yeah, I've seen you guys have been a talent magnet. You've been able to retain a lot of people that are familiar with the operation here in the fab, but also people that have impacted pretty substantial, growth aspects from other facilities are now being attracted here to Polar.
Okay.
So it's interesting. It's almost like this critical mass has happened, and now you guys have this gravitational pull, and people are looking at Polar as an opportunity that is kind of once in a lifetime. Hey, I could be part of something that is a real growth aspect, right? So along those lines,
Mhm.
what has the growth here at Polar meant to the city of I guess
Bloomington.
Bloomington,
Yeah.
and then the state of Minnesota?
Yeah, I'm really glad you brought up the city and the state. They have been, I have to say, amazing partners in this journey with Polar. Uh, Part of the funding comes through the Minnesota Forward Fund, which is a Walls Flanagan administration uh, bill that they passed into law. So we are getting substantial amount of funding for the expansion through the state of Minnesota, Minnesota taxpayers. The city has been absolutely fantastic in supporting us with a lot of the different things that we had to go through in terms of permits and the construction activity and so on and so forth. The city has been a fantastic partner, and they also have been, especially the state of Minnesota, the government has been a great partner in the workforce development efforts that are needed to get the skilled people and to upskill our people to where we need them to be. And I'm actually part of the workforce development board. I'm the chairperson of the workforce development board for the state of Minnesota. So I'm very passionate about um, getting more and more Minnesotans to get into industries like Polar, high tech, advanced technology, high wage, families sustaining type of wages, and with a future. You walk in here, right? Most people like you who are not day in and day out inside the fab, they visit the fab and their jaws drop. This is like going into some kind of sci-fi movie.
It really is.
Yeah.
You see people all gowned up in bunny suits.
Yep.
It looks like, something that a Martian would see or something like that. But, I mean, it's exciting because you see this organized I call it organized chaos.
Yeah.
A lot of moving pieces that are happening here,
Mhm.
but everything is monitored, controlled, and done for a purpose, right?
Yes.
So as someone that is visiting a facility, just like yours, it's you can't be you have to be in awe. There's no other way to put it, right?
Yeah.
So along the workforce piece, what have you
Mhm.
noticed as it relates to getting new people excited about the semiconductor industry? Are you seeing that at the collegiate level? Are you seeing that at the high school level, maybe K through, junior high, stuff like that? Where do you see kind of the opportunity space to get people excited to get into this environment?
You have to get them young. I think we're very it's becoming very obvious to me that you have to get young high school or even middle school students very excited about this industry. And we're working with high schools in the city of Bloomington to get them in a program where they can come and work at Polar. So it's a pre-apprenticeship type of program.
Wow.
So we have that program that's also sponsored through the state of Minnesota. We have a program that we are working with the United States Department of Defense, where we're training engineers who are going to be cleared engineers. And we're working with NSWC Crane, Indiana, and Purdue University in Indiana.
Oh, this must be the scale
This
program.
is the scale program. It's been a fantastic success. We're working with very closely with the University of Minnesota, University of St. Thomas, Metro State University here in St. Paul, to develop cybersecurity type of people, because those are all things that we need. Like as we become, so we're on our path to become a ITAR trusted foundry, and so that means we have to get to the top level of cybersecurity. So we're training people who can come and work at Polar and make us secure from a cyber point of view,
And
data security point of view, IP security point of view.
And that's an interesting wrinkle, right? Because now this opens up an expansion into an area that has a lot of rules and regulations associated with, which is the Defense Department, for obvious reasons, right? Because we have to protect, our national assets, but at the same time, I mean, there's an offensive approach that the United States takes on. So it's interesting yet very opportunistic place to be
Mhm.
in supporting that area. I mean, before we started the podcast, we were talking about some of the extensions into that space, the rad hard area, for
Yes.
example. I know that there's been quite a bit of affiliation with those communities that you guys have not only became members, but now you guys are influencing members into those areas.
Yes.
How big do you see that opportunity kind of growing in the mil aero area?
I think it's a huge opportunity for us. Again, the I'm not going to name the name, but one of the leaders at NSWC Crane said to me that it's in terms of quantity of wafers, the number of wafers needed by the Department of Defense is almost zero. But the value that that relationship adds, it's really an icing on the cake for us. And the Department of Defense needs drives technology. That is very important for us to succeed in the commercial space. The Department of Defense also needs niche needs like rad hard devices. These are things that add to our repertoire of offerings as a foundry. So these are all things that we think give us a huge advantage working with the aerospace business and the military business. Your company and you have helped us kind of understand and navigate the uh, uh, the defense business in general, right? So this is not something that uh, is to be taken lightly. It takes an investment, but I think it is very important for Polar to make this investment. We're already making a large investment in serving aerospace and defense customers. We think that this relationship is only going to grow. I think we're going to be a bigger and bigger part of the national security infrastructure. As a US owned company, we are perfectly suited for that. As a provider of power semiconductors and advanced high voltage semiconductors, and having knowledge of radiation hardened technologies, we are at the right place at the right time.
And it creates a halo effect, right? So, I'll give 2 examples of what I mean by that.
Hmm.
We talked about, rad hard. Obviously, there's, really 2 applications. There's
Yeah.
terrestrial, nuclear related stuff, and then
Yeah.
there's space related stuff.
Yeah.
But when you get into the space, regime, there's national security space, but there's also commercial and civil space.
Yeah.
So there's one halo effect, right?
Right.
The other halo effect I would say is the rigorous sets of testing that the mil-aero ecosystem requires. High reliability,
Yes.
high temperature. There's a lot of these qualification items,
Hmm. Hmm.
which resonates quite well with the automotive stuff you're doing. So the learning curve here is not one where you're starting from scratch. You've
No.
learned a lot of this, but
Mhm.
it gives yet another data point for those automakers to say, okay, Polar is, trust certified. We are relying on them for automotive. We can plan to use them because they know what they're doing. This is
Mhm.
not something that they're trying to figure it out as they go. So
Yeah,
this halo effect is an interesting one, and it goes to multiple other segments as well.
yeah.
I'm just using those two for sake of the podcast here. But now with these investments, right?
Mhm.
You're doing this massive expansion.
Yeah.
Where do you see the horizon for Polar? Is this the first of many opportunities for expansion? Do you see this being, okay, we're gonna, use this as kind of the final end space of the growth for Polar? How do you see the future of Polar looking?
I think there's a much more bigger opportunity than the 14-acre campus that we're in. I think the future is bright for a company like Polar. The things that are driving the future, the AI, just kind of the geopolitics of manufacturing closer to home, the needs of the IoT industry. There's just everything is becoming computerized. Everything has a chip in it. It's just going to get more and more that way. And a lot of those chips are going to be chips that we make. And so there's really a huge opportunity for growth. I think you know I may or may not be here at that time, but I expect Polar to be in maybe 10 years from now, 20 years from now, much bigger than what it is today. And this is the first step of many, many steps we're going to take.
Yeah, I mean, the way you described it at the beginning, you guys have a unique domestic capability,
Yeah.
and with that unique domestic capability, it you don't need to find where you fit in the world. You just need to see how far the bookends are.
Correct.
And with that kind of, knowledge base, I'm hoping that the future does allow for expansion outside of the current campus.
Yeah.
And who knows, maybe there could be multiple campuses that
Yeah,
support these types
I
of.
hope so. And I tell you, I think again, circling back to the people, right? It's all about the people. We have some fantastic educational institutions that produce the best engineers in the world. The Minnesota area, generally the Midwest, upper Midwest area i- is home to amazing universities and research institutions that drive technologies in a lot of these things: radiation hardened electronics, semiconductors, magnetic type of materials that also become part of semiconductors. There's a serious level of expertise that lives in this area. And it is just, for us to take all of these technologies to the next level. It's an opportunity for Polar to take it to the next level. And at the same time, serve the national security, economic security, and supply chain resilience of the United States.
Absolutely. Well, Surya, thanks a bunch for joining us here on the podcast. It's exciting
Yeah,
to see the facility, the expansion, the enthusiasm here. I mean, you see it right when you walk in, with the first person you meet at the security gate,
mhm.
to the people that are tried and true, been here for a while, as well as the new additions. So looking forward to seeing how this continued growth happens within Polar and the big dates in the 26, 27 when, phase 2 of the facility is opened up. So, thanks a bunch for joining us.
Yeah, thanks for the opportunity, and we'll be happy to host you again. A year from now, 2 years from now, or anytime.
Look forward to it.
Yes,
Thanks.
thank you.